Hey guys, this is a homework help video. I have done 3 of the odd problems that are mixed within the homework problems that I assigned you in the hopes that these examples will help you guys complete your homework. The first problem that I looked at was problem 31, which is very similar to the problems we did at the end of class today. It's still Wednesday in my world. And the first one we see here wants you to multiply zero point 0.8 times both your standard deviation of y and your mean of y. And if you want to multiply something by your mean, you simply do just that. You multiply it. So the mean in this problem for y is 300. So when I do 0.8 times 300, I get 240. And then if you want to find the standard deviation, we only work with variance. And variance is simply standard deviation squared. So notice that I still use the word or the letters SD for standard deviation, but I made sure to square that 16, which was the standard deviation. And if I square it, that is the variance. And then we multiply the variance by the multiplier squared. And then, of course, to get that final answer, you take the square root, and I get that 12.8. On part B, they want us to find the expected value and standard deviation of 2 times x minus 100. And the mean for x was 120. So sorry, let me highlight that. Was 120. And so you simply multiply it by the multiplier and then subtract the 100 and you get 140. Easy peasy on that one. Now, standard deviation is just a little trickier. We do not do the shift, so that minus 100, we will not mess with it when it comes to standard deviation. We will simply multiply it by 2. And when we multiply by 2, we make sure to multiply by the square of the multiplier. And then we have to work with variance. So variance is whatever that standard deviation was squared, and then we take the square root. And I think a better place for me to have had, and I want to make sure I pick the same color, I should have had the 2 on the outside of this. And then standard deviation of x, like that. On part C, we are going to be adding 2 different means to each other and then 2 different standard deviations to each other. When we add 2 different means to each other, we have the expected value of x and then the expected value of y, and then they want us to multiply 2 by that expected value of y. So we simply do 120 plus 2 times 300 because those were the means in the problem. And then you get 720. Now, when it comes to standard deviation, you're going to follow the same process, but keep in mind standard deviation is not part of the formula. The formula only works with variance. So we take our variance and we square it. Or sorry, our standard deviation and we square it. So that is technically the variance right there. And then on the second one, there's a multiplier. So we have to square that multiplier. And then we're going to square that standard deviation because, once again, we're working with variance. And then you just take the square root of that and you get 34.18. Now, moving over here, part D, same exact process. This time there is a subtraction sign. And so when we're dealing with means, we still subtract. I have posted a great video. You'll see it on our Google Doc for this unit from Khan Academy that he explains in detail why this minus for a variance ends up being a plus right here. And so it's a really good video, and it does have to do with those negatives being squared. Either way, if we are working with the expected value and we subtract, then we do just that, we subtract. There was a multiplier that I had to take care of here, and I get an answer of 60. Now, when it comes to the standard deviations, we do only work with that positive since we're working with those squared values. And there is a multiplier right here, so notice I made sure to square my multiplier. I'm squaring both standard deviations because I can only work with variance, which is your standard deviation squared. I substitute the appropriate numbers in here and then just take the square root and I get my answer. They start to almost be repetitive. You start to see the same thing happening. When I add the expected value and I'm just doing the expected value of y to itself, I list it out as y1 and y2, and the expected value of y1 plus the expected value of y2, 300 plus 300 equals 600. Yay. Now when I do the standard deviation of y, I have to make sure to do variance plus variance. And variance is simply standard deviation squared. And here my standard deviation was 16, so my variance is 16 squared plus 16 squared. And then if I take the square root of that, I end up at my standard deviation of 22.63. Okay. Question 35 says a grocery supplier believes that in a dozen eggs, the mean number of broken ones is zero point 0.6. Okay, so the mean number of broken eggs is 0.6, and the standard deviation of broken eggs is 0.5. And it says you buy 3 dozen eggs without checking them. How many broken eggs do you expect to get? Well, when I first cranked this problem out, I thought that it was a multiplier of 3, and I wasn't thinking it completely through. Think about it. You were buying 3 separate cartons of eggs, so you're adding 3 things together. So that's where I end up. Uh-oh. There we go. Sorry. That's where I end up with the plus 6 plus plus 6 plus, sorry, 0.6 plus 0.6 plus 0.6. Let's see if I can get this problem finished. On the next one, I am taking my standard deviation of x1, my standard deviation of x2, my standard deviation of x3, which is really the variance plus the variance plus the variance. And I say variance, I'm simply writing SD squared. That is the variance. And so it is standard deviation squared, that is the variance, standard deviation squared, that is the variance, standard deviation squared, that is the variance. And I take the square root of that, and I get 0.87. And the very last question says, what assumptions did you have to make about the eggs in order to answer this question? That those cartons are independent of each other. Okay, there can't be dependency going on here. So independent of each other. The last problem that I want to look at is problem 39. It says that back in chapter 5, there was an equation called the SAT, or that was SAT equals 40 times ACT plus 150. That's just a way that you can convert an ACT score into an SAT score. Let's use this transformation again now with random variables. Suppose your school has a mean ACT score of 29. That would be awesome. What would its equivalent mean SAT score be? Well, I simply do the operations here. I multiply by 40 and add 150. That's all you do. Now for standard deviation, because that's the next question, it says if your school has a standard deviation of 5 ACT points, what's the standard deviation of its equivalent SAT score? And that means we have the formula. And let's see, we've got that 40 times the ACT plus 150, but we will ignore the plus 150 for standard deviation, so we simply have a multiplier of 40 to deal with. We have to square our multiplier. We know that 5 is simply the standard deviation, so we change it to a variance by squaring it, and then we take the square root of that, and we get 200, and we are done. I hope these examples help you guys complete that homework. I'm also going to do a video of the notes that I didn't finish, and so then you can really complete all of your homework at that point. All right, thanks, guys.